So let's take a first look at the standard Keynesian model, a short-run model, where aggregate demand or planned expenditure determines GDP. So we define planned expenditure or aggregate demand. So in economics we often use aggregate demand. Michigan uses planned expenditure to be the sum of its components, consumption plus investment plus government spending plus net exports. Consumption is given by a consumption function. C bar is autonomous consumption, MPC is the marginal propensity to consume, and you consume out of disposable income, which is GDP minus taxes. We could also have consumption depend negatively on the interest rate, right, R, so if we wanted to have a more complex consumption function, we could put that in there. We have investment demand, or planned expenditure, which has an autonomous component, I bar, and then investment depends negatively on the interest rate that faces people wanting to carry the investments, which is the sum of two components in Michigan's model, which is the real interest rate R and financial frictions F. So the bigger our financial frictions, the harder it is, or the more expensive, the more costly it is for firms to find the financing that they need in order to expand their businesses. Then we have net exports, which depend negatively on the interest rate. Also, the reason they depend negatively on the interest rate is because the higher the interest rate, there'll be an appreciation of the currency, which makes our exports more expensive abroad and makes imports from abroad cheaper, and so net exports decreases. And in our model, we're going to have government spending and tax exogenous. We're not going to model how the government determines its tax and spending policies. So our equilibrium condition then is that GDP, our actual output, equals planned expenditure. So GDP equals aggregate demand in equilibrium. So we can now substitute all those equations in, and we get GDP equals planned expenditure, which is the sum of all of its components. Well, now we're substituting in for all those functional forms. We do the algebra, collect all the y terms. We have that one here. We bring it over to the other side, factor out the y, so we have 1 minus MPC, then divide through the whole equation by 1 minus MPC, so that's why we get this 1 over 1 minus MPC here and 1 over 1 minus MPC here. And we collect all the terms that are exogenous consumption terms, and then here the factors that are multiplying the interest rate, and we have the interest rate here. So that's all just algebra. You can see how Michigan does it in the textbook. Now we have a relationship between y and R, a relationship between the interest rate and GDP, and that relationship is called the IS curve. And it's important to remember that this IS curve represents the set of all equilibrium levels of the interest rate and GDP, where planned expenditure equals GDP, where aggregate demand equals GDP. So this is we graph it as a line. It's really a set of points, right, on the graph. It's a set of combinations of interest rate and GDP, where GDP equals planned expenditure. So I'll say that again. So this line, the IS curve, shifts out. So will be shift out to the right if any of these exogenous components of spending increase. So higher government spending shifts out the IS curve, higher net exports shift out the exogenous component of net exports. An increase in financial frictions, higher F, shifts the IS curve towards the left. So pretty straightforward. What do we do with this IS curve? Well, not much now. What we need to do is then think about what determines the interest rate, and Michigan's going to make the modeling assumption that the interest rate is determined by the central bank. The central bank has what's called the monetary policy curve. It's usually called the Taylor rule, where it sees what inflation is, and because the central bank has a mandate to try and limit inflation, and because the tool of the central bank basically is to affect the real interest rate, and that's how it can affect inflation, when the inflation rate is higher, the central bank sets its monetary policy to have a higher real interest rate. And so we have this upward sloping MP curve. So at any at any inflation rate, the central bank, through its Taylor rule, through its marginal monetary policy curve, determines an interest rate. And this is the equation, the simple equation that we'll be using. R bar is a choice variable for the monetary policy authority that we'll think of as determining whether monetary policy is loose or tight. So the higher is R bar, the higher is the MP curve, the lower is R bar, the lower is the MP curve. So the monetary authority has two policy choices in some sense. First is how it reacts normally to inflation. When inflation goes up by 1 percentage point or 2 percentage points, lambda here determines how the central bank is going to change interest rates. And then the central bank occasionally, every couple of years, in response to changing macroeconomic circumstances, in particular the unemployment rate, might decide to tighten or loosen monetary policy. That's a shift in monetary policy. So that's the MP curve. We can now bring the MP curve together and say, well, for any given inflation rate, the central bank sets an interest rate. That interest rate determines how much GDP will be. And so we have a relationship now between inflation and the level of GDP. And it's a negative relation, and we call that relationship between inflation and GDP the aggregate demand curve. So for a high level of inflation, the Fed will set a high real interest rate. Investment spending then will be low. The exchange rate will be appreciated, and so GDP will be low. For low levels of inflation, the Fed will set a low real interest rate, and investment will be high, net exports will be high, and so GDP will be high. So that's how we derive this aggregate demand curve, a relationship between inflation and GDP. We only have one thing left in our model, really, which is to add an aggregate supply curve, and that way we'll have a complete model determining inflation and GDP, which are our main macroeconomic variables of interest. We'll save that for another time.